How big is the universe? The size of the universe is one of the most fascinating and mind-boggling questions in science. It's a topic that stretches our imagination to the limits, and even the best scientific minds are still exploring just how vast and expansive it truly is. When we think of the universe, it's easy to picture stars, planets, and galaxies scattered across the night sky. But the true scale of the universe is far beyond what we can see with the naked eye, or even the most powerful telescopes. To understand the size of the universe, we need to explore a few key concepts, including light years, the observable universe, and what lies beyond. These concepts help us piece together just how massive everything is, and why trying to grasp the universe's size is like trying to visualize infinity. The speed of light and light years. Before diving into the size of the universe, it's crucial to understand how astronomers measure distance in space. Unlike on Earth, where we use kilometers or miles, space is so vast that we need a different unit of measurement. Enter the light year. A light year is the distance that light travels in 1 year. Light is the fastest thing in the universe, moving at an astonishing speed of approximately 300,000 kilometers per second, about 186,000 miles per second. This means that in just 1 second, light can travel around the Earth 7.5 times. Over the course of a year, light covers about 9.46 trillion kilometers, or nearly 6 trillion miles. That's 1 light year. Now you might be wondering, why use light years at all? Well, distances in space are so enormous that using kilometers or miles would result in numbers that are almost impossible to comprehend. By measuring in light years, astronomers can more easily communicate how far away objects in the universe are from us. The observable universe. The term observable universe refers to the portion of the universe that we can see or detect with telescopes. This is not the entire universe, just the part we have access to based on the light that has had enough time to reach us since the universe began. Our universe is believed to have started with the Big Bang around 13.8 billion years ago. This means that the farthest objects we can see are limited by how long light from those objects has been traveling. The light from the most distant galaxies we observe today started its journey toward Earth billions of years ago, shortly after the universe formed. Given that light travels at a fixed speed, and the universe has been expanding for nearly 14 billion years, you might assume the observable universe has a radius of 13.8 billion light years. However, because the universe has been expanding the whole time, the actual radius of the observable universe is much larger, about 46.5 billion light years. This makes the observable universe roughly 93 billion light years in diameter. To put that into perspective, a single light year is nearly 6 trillion miles, so a 93 billion light-year wide universe is incomprehensibly vast. But remember, this is just the observable universe. There may be much more out there that we simply can't see because the light hasn't had time to reach us yet. Beyond the observable universe. So what about the parts of the universe that we can't see? Does the universe have an edge? The truth is, we don't know for sure, but most scientists believe that the universe extends far beyond what we can observe, possibly even infinitely. Imagine blowing up a balloon. As the balloon expands, any dots drawn on its surface move farther apart from each other. This is similar to how the universe expands. The galaxies within it aren't moving through space, but rather space itself is expanding, carrying them along. Since we're inside the universe, we can't step outside of it to look at its total size, but the analogy of the balloon helps us understand the concept of continuous expansion. There are a few possible scenarios for the overall shape and size of the universe. One possibility is that it's infinite and goes on forever. If this is the case, then the universe is literally boundless. No matter how far you travel, there's always more to see. Another possibility is that the universe is finite but unbounded, meaning it wraps around itself like the surface of a sphere. In this case, if you could travel far enough in one direction, you'd eventually end up back where you started, though that would take an unimaginable amount of time. Regardless of whether the universe is finite or infinite, it's clear that the part we can observe is only a small fraction of the whole picture. Expanding universe and dark energy. One of the most remarkable discoveries of the 20th century is that the universe is expanding. In 1929, American astronomer Edwin Hubble observed that galaxies were moving away from us, and the farther away they were, the faster they were receding. This led to the conclusion that the universe itself is expanding in all directions. The rate of this expansion is determined by something called the Hubble constant. However, the discovery that the universe is expanding didn't just stop there. In the late 1990s, astronomers made the shocking discovery that the expansion is actually accelerating. This means galaxies are moving away from each other at an ever-increasing rate. The force driving this accelerated expansion is known as dark energy. Although we don't fully understand what dark energy is, it's thought to make up about 68% of the universe's total energy. Dark energy acts like a mysterious repulsive force that's pushing the universe apart, causing it to expand faster and faster. If this continues indefinitely, the universe will become increasingly stretched, with galaxies moving so far apart that they become invisible to each other. Galaxies, stars, and planets. To truly grasp the scale of the universe, it's worth considering the vast number of galaxies, stars, and planets within it. Our solar system is just one small part of the Milky Way galaxy, which contains over 100 billion stars. Some of these stars have their own planets, just like our Sun does. And the Milky Way is only one of billions of galaxies in the observable universe. Each of those galaxies contains billions or even trillions of stars, and it's likely that many of those stars have planets orbiting them. This means that the universe contains an unimaginable number of stars and planets, far more than we can count. One particularly mind-bending fact is that there are more stars in the observable universe than there are grains of sand on all the beaches on Earth. If you've ever picked up a handful of sand and tried to count the grains, you know how impossible that task is. Now imagine the entire Earth's worth of sand and multiply that by a factor of billions. What lies beyond? The question of what lies beyond the observable universe is one of the most intriguing in all of science. Since we can't see beyond the limits of our observable universe, everything we know is based on what we can measure and detect. But there's no reason to believe that the universe simply stops at that boundary. It's possible that the universe continues on forever, filled with galaxies, stars, and planets similar to what we see in our observable region. Alternatively, the universe beyond could be vastly different, filled with entirely different forms of matter, energy, and even physical laws. Some scientists propose the idea of a multiverse, where our universe is just one of many universes, each with its own distinct properties. While these ideas are speculative, they underscore just how much we still have to learn about the universe and its size. Even with all of the technological advancements we've made in astronomy, we've only scratched the surface of understanding the cosmos. The future of the universe. Given that the universe is expanding at an accelerating rate, what does the future hold? There are several possible outcomes, depending on the properties of dark energy and how it behaves over time. One possibility is that the universe will continue to expand forever, gradually becoming colder and more desolate as galaxies move farther apart. Eventually, all the stars will burn out, and the universe will become a dark, cold place known as the Big Freeze. Another scenario is the Big Rip, where the expansion accelerates so much that it eventually tears apart galaxies, stars, planets, and even atoms. This would be a more dramatic end to the universe, but it's still many billions of years away. The size of the universe is one of the most awe-inspiring and humbling concepts in science. With a diameter of around 93 billion light-years for the observable universe, and the possibility that it extends infinitely beyond that, the universe is truly vast beyond our comprehension. As technology advances, we'll continue to explore its depths, but for now, we can only marvel at the incredible scale of the cosmos and our small place within it.